All right, we're now learning how to prove that events are independent or not. Determine whether mathematically if two events are independent. So, for example, if you have blue eyes, is that independent of you being smart? That kind of thing. How one of first event does not affect the outcome of the second type thing. Okay? So that's the idea behind the what an independent event is. Two ways to prove two events are independent. The first way is to show that the conditional probability is equal to the original probability. So, for example, the probability that I am smart, given that I have blue eyes. So, this is smart, this is blue eyes. Is that equal to the probability that I am smart? Okay, then that would mean that they would be independent. This one here, the second way to show is the probability of A and B. So the probability that I have blue eyes and I am smart. If I multiply the two individual probabilities together, if that's equal to the intersection or the probability that they would both occur. So those are the two independent. We have another independent formula. That's the word I'm looking for. We have another one that we're gonna talk about, but that really only works with tables. Obviously, like you'll see when we get there, I guess. Okay, so for example, this one gives you probability of A and B, and A and B. So that looks like this formula. So that's the one I'm going to use. And that's generally how it works, where you're given a bunch of probabilities and you have to decide which of the two formulas that work best. Okay. So probability of A and B, is that equal to the probability of A times the probability of B? So we just set it up. A and B is 3 over 20. Probability of A is 3 over 5, and the probability of B is 1 over 4. This is 3 over 20. That is equal to 3 over 20, not 30 over 20, 3 over 20. Oh my goodness, it could be any more annoying. So check, these are independent. Okay. And that's it. That's the idea behind this one. So just an example of, I guess, this situation. So probability, same deal here. We have A, B, and A and B. They can write the word and, or we can put a little symbol. They mean the same thing. So you should write your formula out so we know how you are planning on proving it. So A and B is 3 over 50. Probability of A is 3 over 10. Probability of B is 1 over 4. So do the math. 3 over 50 is not equal to 3 over 40. Sometimes it's easier to write it as a decimal to see that they're not equal, so that's also allowed. As long as they're both decimal or both fractions, it doesn't make any difference. All right, number 3. So this one uses the given conditional, the conditional probability. So that would be that formula. So the way that this formula works is the probability of A given B is equal to the first one. So if this is the conditional probability, it's A that is equal to. If those are true, then it's independent. So A given B is 1/5. Probability is A is 1/2. These are not equal, so not independent. I don't know if I didn't write that on the last one. I didn't. Okay, so number 4, we have A given B. So A given B here. So that's equal to, is that equal to the probability of A? That's what we're looking for. So this is extraneous. It's not information we really need. So is 9 over 20 equal to 9 over 20? By golly, it is. So these are independent. And that's how this works. You just have to practice using the formula and making it work. Okay, an alternative way that we can use that is if you're told A and B are independent. So if you know they're independent already, so then you know you can use those formulas to find other things. So if this is A and B, if they're independent, I know that A and B is equal to the probability of A times the probability of B. So I know that 11 over 80 is equal to 1/4 times the probability of B, which I'm going to call X right now. All right, and then you just solve. Divide by 1/4 or multiply by 4, whatever makes you happy. Do that, and you wind up getting 11 over 20. So that's your X, or as I said, X is B, so it would be 11 over 20. That's exciting. So here we have more examples. We have another and, so the probability of A and B is equal to the probability of A times the probability of B. So A and B is 30, and we already know they're independent, 39 over 100. That's equal to 13 over 20. We'll call that X. It's just easier to write. Divide by 13 over 20. And when you do the math, you get 3 over 5. Amazing. These are even easier, just because there's no actual math involved. Because if we have the probability of B given A, that's absolutely equal to the first one, or the probability of B. So B given A is 3 over 10. That's equal to the probability of B. I'm done. If they're independent, then A doesn't matter that A occurred. Okay, so same deal here. Probability of A given B, that's equal to the first one, the probability of A if they're independent, so it's 11 over 20. And again, just like the last time, that was just extra information. Okay, so sometimes we're not given it in symbol form. If we're given it in symbol form, it's pretty easy, nice, and cheesy. But if we don't, then we have to figure our information out. So we have they're given probabilities. So as we know, if you have a probability of an event occurring or a series of events occurring, the total probabilities all added together is 1. So we have the probability, a study of Newfield teenagers found that they listened to loud music. So loud music is, that circle would be 0.15. Also found the probability that a student has hearing loss is 0.4. So this is hearing loss. That's 0.4. The probability they do not listen to music or have hearing loss. So that's an or situation. So that's our 0.15 plus 0.4 minus the or, which would I say 0.1, oh, 51. Just we wind up getting 0.05. So 0.05 have both. And then from there, we just do the rest of the math. So this would be 0.1 here, just loud music. This would be 0.35, which is just hearing loss. And this one down here, neither would be 0.51. So filling out the Venn diagram, that is that. Are these two events independent? So you could use either of them. I find the easiest one to use is the and one. If you do it the other way, if you use the other probability, the other independent formula with the given, you have to do both ways. So you'd have the probability of A given B and B given A. And you know the conditional is slightly annoying. So the and is a lot easier in general. So it's the probability of loud music and hearing loss. Is that equal to the probability of loud music? Oh my God, kill me. Sorry. Loud music times the probability of hearing loss. So these have to be probability. They can't be how many's. So the and is 0.05. Probability of hearing loss, of loud music is 0.15. Probability that they have hearing loss, that's this one. I hate when I use the same letters for the same things. It's kind of annoying. So this one right here is equal to 0.6. This is 0.05. They're close to independent, but they are not independent. And it's as easy as that. Okay, so we have this situation here also. Nathan plays baseball today. The probability that Nathan plays baseball today is 0.45. The probability he plays baseball given that it's raining is 9/20. Are these two independent? So this is a given probability. So the probability that he plays baseball given that it's raining, is that equal to the probability that he plays baseball? Remember, it has to be. So if we're given this conditional, it has to be this one. So that's exactly what they gave us. So is 9/20 equal to 0.45? Leaving it like that isn't obvious, so you really should make them either both fraction or both decimals. So if you do the math, it's 0.45. So these two are equal, so they are independent of each other, unfortunately. All right, have a wonderful day.